Hello. This time looking at the AC Ohm's law quiz topic, which is just the same sort of thing as we did with Ohm's law in the first quiz, except using the complex impedances of the components rather than just their resistance. As a quick reminder, the impedance of a resistor is just equal to the resistance. The impedance of a capacitor is equal to 1 over j omega times the value of the capacitance in farads, and the impedance of an inductor is j omega L, where L is the inductance in henries. And with those formulas you can just use Ohm's law and work out the AC performance of circuits. Right, let's have a look at a few. Level 0, simple ones. So, this is a resistor. For a resistor, the voltage across the resistor and the current flowing through the resistor are in phase. We know the phase of the current, it's minus 50 degrees, therefore the phase of the voltage must be minus 50 degrees too. So that's easy. The magnitude we can work out by just taking the current times the resistance, just the same as Ohm's law. So in terms of magnitude, we've got 147 microamps times 6K8. In terms of phase, we've got minus 50. And I input phase by using the at symbol. At minus 50. Oops. Minus 50. So that would be a phasor of amplitude 147 micro times 6K8 and phase minus 50 degrees. It's degrees because I've selected the degrees radio button over here. If I wanted to work in radians, I would just click that there. But I'm working in degrees. So that should do. Next. Here we've got a capacitor. And for a capacitor, the current is 90 degrees ahead of the voltage. If you've come across the acronym CIVIL, capacitance, current, before voltage. So the voltage is 90 degrees behind the current. So if the current is 170 degrees, the voltage will be 170 minus 90. 80. So we know the angle, 80 degrees. Now, how about the magnitude? Well, for the magnitude, we can apply Ohm's law again, but this time Ohm's law is going to be V equals I times ZC. And ZC is 1 over j omega C. So to work out the magnitude of the voltage, we're going to need to know the magnitude of I over omega C. Omega is in radians per second. So the voltage is going to have a magnitude of the current, 10 nano, divided by the frequency in radians times the capacitance in farads, which is 2 times pi. I can just type pi for pi here, times the frequency in hertz, 10k. So that's omega, that's the frequency in radians per second, multiplied by the capacitance in farads, 220 pico. So that is the magnitude. And then I could just say y at x, which is a phasor of magnitude y and phase x angle of x. Great. See if there's any other ones. Oh, one other thing that I was going to mention, changed since last term, is that if you type in a syntax error, for example, I could type in here 68 microvolts divided by 100 nanoamps, and that is a syntax error because they're unbalanced brackets. But that is no longer marked wrong. That is now marked can't understand, and you don't get an automatic halving of the score if you put a syntax error like that. Now it gives you another chance to get it right. I think that's about all you need to know for doing these problems. It was really just how to enter phasors with angles and magnitudes like that. You can also, by the way, enter them in the form 120 plus 60j, and it will work out that and express it in terms of magnitude and phase as well, should you wish. Right, I think that's all you need to know to get started with topic 17, AC Ohm's law.